Section 4.2, Linear Approximations and Differentials. Now, the book seems to have forgotten that we already did this back in section 3.4. But being that they have it, listed again, I will go ahead and have us go over it again. That is the linear approximation, which is the tangent line at any given point of a function f. The tangent line, as you might remember, is called y equals to f of a, and then plus f prime of a times x minus a. Now the tangent line, being that it's close to the original function, okay, like say if you have a tangent line, the function, then you have some tangent line at some point, where it's nearby to the point, the tangent line is almost the same as the function. If the function is differentiable at this point, it has a tangent line. So therefore, the tangent line can be used to approximate the function itself. So then we can rewrite this function as L of x, y equal to L of x, equal to f of a, which is the fixed point. For now, we're only considering one point on the function. And I'm on page 355. Okay, L of x equal to f of a plus f prime of a times x minus a. And this is this is just the tangent line rewritten with a different name, and it's also called the linear approximation. Now, having said that, as you can see, it's just the tangent line is very straightforward. So I'm not going to go over it. Please do example 4.5. It is very straightforward, and I think you won't have trouble understanding it. You probably can read it faster than I can explain it. So please do, for homework, example 4.5, and then 4.6, and then 4.7. They continue to have you work on the tangent line, which is straightforward, and then now we get to page 358, where I want to talk about the differentials. Now the differentials are basically the same thing or similar thing as the tangent line, but it's called by a different name. Now the differential is, what is it? But the differential looks interesting, okay? Which is why it makes quite clear fun. Please focus on page 358, and towards the bottom of the page where it says 4.2, okay, where the equation 4.2 at the bottom. I don't know. I can't. It isn't very clear. Doesn't matter. The point is, it's at the bottom. At the bottom of the page, where it says, "Let dx be an independent variable that can be assigned any non-zero real number." So we have dx. dx is one variable. Okay, this is probably one of the first times in your life that you consider two letters to be one variable. In other words, dx is like, say, x or something. Normally we have x, that's an independent variable, and then y. When you have a function y equals to f of x, x is called an independent variable because x changes, and y is dependent on x because y depends on what x is, and then you calculate, and y is the result. So y is called a dependent variable. But now we're going to define, okay? We're going to call dx, which is something we haven't seen before. We're going to call dx as a new independent variable, and it's defined, okay, that can be any number except 0. And then we're going to define dy with this relationship. Dy equals to f prime of x dx. So then that is for a specific x, then we'll calculate f prime, and then the dy and dx has this particular relationship. Now, like dx, dy is also a variable together. Okay, 2 letters, 1 variable. So dx is similar to, is like kind of like x, in the x is a variable, but x is independent, whereas dy is like y, whereas dy is the dependent variable. It depends on what this value is. And then so then, as you can see, then of course dy over dx equals to f prime of x. Now you have seen this before, right? This is normally the derivative of y. As I've mentioned before, this thing is not a fraction. But for this particular notation, this is now a fraction. Now that might sound a bit confusing, but it's not. Okay, because we're using the same notation to mean something different. It happens in languages all the time. And that's why, and you will know by context whether this is the derivative or the differential, and they even sound the same, so they can get slightly confusing. But the relationship itself is not profound at all. dy is some variable independent, and then dx is some independent variable, and the only thing it's good for is when it multiplies by f prime of x, it becomes dy. That's all there is to it. So it's a direct multiplication relationship. And therefore, when you do division, the dy over dx equals to f prime of x. So at this point, being that this is true, then it helps. This is kind of helpful because the other meaning of dy by dx in this notation also means this. So the two meanings kind of help each other. It helps you remember what dx is when it has the separate meaning of a separate meaning of being a differential instead of a derivative. Now, having the same letters to represent different meanings happens in English all the time. For example, the English word cleave, okay, it means to cut something apart, right? But it also means to stick something together. It means it means both things. Isn't that cute? That's the word cleave. I just looked it up to make sure that I'm right. Yeah, cleave means stick together or break apart, whichever one you want. Anyway, so that's how you remember that the dx by itself is a differential and is an independent variable. So after having said that, please do the homework, because it's basically the same thing as this. Okay, and I think it'd be faster for you to just do the homework than listen to me explain how to do this one-step multiplication. So the next one, next homework I like you to do is example 4.8, 4.9, and 4.10. We're all calculating dy or some such thing, and you're approximating. Again, this is approximating, but however, there is one thing I should mention on page 361. That is a quick mentioning is the delta y. Okay, now the delta y, which is defined, this is again one variable. Okay, delta y is defined as something like is f of a plus dx minus f of a. That is, delta y is the change in y. That is, the f, you calculate the difference of the function when it moves over by a little bit. So that's the meaning of delta y. Delta y is the actual difference, whereas dy is the approximation. Because dy, you're just taking dx and multiply by f prime of x. So you come up with a difference, whereas delta y is the actual difference. So sometimes you can check the difference between the two to see how good your approximation is compared to the actual answer. All right, so to know exactly what I mean, please please do the examples as homework, 4.10. And then the last one, more errors and stuff, 4.11. And with that, that should be good enough. And like I said, this section has already mostly been covered in section 3.4. So we will skip that and go to the next chapter. Next section.